we will see some of the special topics today, starting with negative skin friction, and then scouring, seabed subsidence, and then the soil issues associated with carbonate content, which downgrades the capacity, and then the piling issues related to refusal, and then if the refusal occurs, what else we can plan at site, unforeseen issues. Can we do repair works, something similar to adding additional piles, or do we have planned activities? And then finally we will come to the connection between the pile and this jacket. I think one of the connection we have already seen, the skirt pile connection with grout between the annulus of the leg and the pile, we have already seen in the previous session. So we will just go through some of them which are quite important in the sense, in case if it occur, it may actually affect the capacity of the pile very seriously. So we will start with negative skin friction, which is not very much prone to offshore systems, because this is a problem where the piles are installed in a filled ground, especially the recent fills. For example, if you go to this picture, you will be able to understand a little easier. If you have a filled area, probably like in the cities where you have got a recent fill, and then try to install a pile foundation wherein you have slightly better stratum, few meters away or few hundred meters down. So when you try to install a pile, something like this, and you see the soil which is recently filled and has consolidation characteristics, it could be clay or it could be sand. So when the soil settles down, instead of the pile soil interface providing frictional resistance, is exactly opposite. The soil is going down and it gives the down drag. So the weight of the soil is acting downwards. So instead of enhancing the capacity, is going to add to a problem which is adding to the load. So this we call it down drag, negative skin friction, additional loads in addition to the load applied to the pile. You have a pile load coming from your structure, but then the soil in the vicinity is getting added because of the frictional resistance between the pile and the soil, but unfortunately the soil is going down. So this problem is not so much, because we do not actually install any places where soil is filled in offshore conditions. You don't expect, but this kind of problem is very much there in the onshore as well as coastal areas where you have a fill. So we just look at the issues and how it occurs is the relative movement between the fill and the pile shaft, which is, so that means if the soil, after the installation of the pile, if the soil, the top layers settles down, that causes this problem. And the elastic compression of pile under working load, sometimes you may have small displacement, and that you can take it minus. The rate of consolidation of compressible layers below, though the top layer may be not settling down, but if there is a clay layer slightly below and that layer get compressed, the top layer comes down. So it is a complex problem which is very difficult to predict. So that's why pile type of foundation is not recommended when you have the fill soil for the top layer. Also it depends on what is the type of bearing stratum. Suppose if you have a very hard bearing stratum, the pile is fixed down there. Imagine if the pile is not fixed to the basically the hard ground, if it is floating pile, the whole soil layer together with the pile will go down. So the relative movement is not going to be so much a problem, whereas here the pile is not going down, it is going to take the load and then try to yield at the bottom. So that is the problem. So whenever you design a end-bearing pile, you make sure that the top soil layers are not prone to too much of settlement, which is going to cause exactly opposite problem to the pile capacity. So there were several proposals how the down drag will vary. So if you look at the picture on the left side, you see here the top layer or the initial few meters of the soil is going to cause a lesser down drag, because the cumulative consolidation will happen. The total added weight will be increasing the effect of down drag at the bottom level. So it's a simple idea. Of course, all depends on the type of soil. If it is a uniform soil, you may actually come up with something like a triangular distribution, which is what you can see here. So increasing effect, and then probably the effect is not much after certain depth, and then going to not much effect because the pile, the relative movement is very less, because the pile is almost fixed to the or hard ground. So, this is a kind of assumptions that we will normally need to make during the evaluation of down drag. So, you can see here top 10% not quite a small value to increasing to the maximum value, and then this is 0.8, the 0.8 is missing here. So, the 80% of the pile will be having uniform down drag, then the last 10%. So, it is a kind of simplified assumption in order to do a design activity rather than taking a highly non-linear profile, something which was measured in some of the sites. So, install a pile, do a instrumentation to measure the friction, and then you look at this profile something like this. Similarly, if you have a pile not installed in hard, but installed in a soft layer, something like this, you see here the variation is also considerably different. And here you can see here the lower side there is the soil also going to move together with the pile, because this is again not a hard layer. So, you can see a slightly different arrangement of the profile of assumption. So, whenever you have such situations, you have to reasonably assume certain profile, and typically you can see the top and bottom is not going to contribute too much. The middle layers where the whole thing is moving down is going to contribute to the negative skin friction, which in some cases can actually cause a big problem. If you install a coastal area where you install a pile of 20 meter and make sure that the pile is going to end bearing, your assumption of loading may be 100 tons and you provide a 100 ton capacity, but if the soil layers compress and displace, the addition of load can be several hundred times several times higher than the actual load 100 ton comes. So, pile will immediately fail because of this kind of problem, because the pile will start yielding at the base, because the soil layers also is provided as the load. Some of the piles have failed like that, and in fact some of the structures have collapsed because of this kind of phenomena constructed on fill. Of course, this problem is not so much for offshore as I mentioned earlier on, but still just to understand what is the problem if you have a top layer settlement. So, you need to just understand this fact. So, typical design profile given by one of the codes, not Indian codes, is one of the Euro code, of course taking several sub-segment of the profile, increasing and then again increasing in a slightly typical values of skin friction. Remember, we were talking about calculation of alpha value using alpha method for actual capacity, and in here as the depth increases the down drag also reduces. So, that is the kind of profile given by the code which is taken from the Euro code, and I just plotted. Unfortunately, most of the other codes does not give any guidance. So, that is why I have taken this profile. So, how do we minimize skin friction in case if you have to install piles in the area where some top layer fill is expected? So, you could actually delay the construction, that means you allow the consolidation or immediate settlements to happen. So, wait for 6 months, 1 year, 2 years, or you actually accelerate the settlement by means of overloading. Several places in onshore construction people do this by stacking heavy weights. So, if you are having a fill is fine, but then you make the consolidation settlement 90% of them or more happening before you construct the structures. So, by doing this you minimize the amount of settlement that is going to happen post construction, but then all depends on the time. And basically several methods of soil improvement techniques, which I think we are not talking in our course, but it will be very important. One of the technique is relieving pore pressure. Imagine if you have a fill soil with pore pressure or the water surface below. So, you can actually have several holes drilled into it, and somehow you have to drain the water. So, you actually do a surcharge loading and make the water to come out. So, we have so called band drains. You insert the drains, vertical drains, and with the perforated holes. So, the soil will squeeze because you are applying a loading, and the water might come out through the pore and then relieve pressure. That means settlement happen very fast. So, that is the idea of so called the soil improvement techniques, one of them. There are several other techniques which can be used, so that the settlements, if it is required to happen, let it happen before the construction of the structure. The other method is basically a active way of doing it, coating the pile surface with bitumen or other which reduce friction. See, actually when you design a pile, we wanted more friction because of increasing effect and the frictional resistance, you will get better capacity. This is exactly you are trying to provide opposite, so that the alpha value will be lesser. So, the pile soil interface we want to make it smoother, so that the down drag does not cause too much of the effect on the loading. So, that is the opposite. Normally use bitumen coating or other surface coatings which reduces the frictional resistance. The second topic which we want to see is the seabed subsidence, which is very much prone to offshore platforms constructed in the local vicinity, several of them. As much you want to know this, why it happens, we need to know where we are taking this the oil and gas, mostly several 1000 meters below the seabed. Mostly I think in the starting of the course we were talking about several kilometers, 6 kilometers, 5 kilometers below seabed is this kind of hydrocarbon deposits are available. Now, if you have only one drill because of one location, it is nothing going to be a problem, but you can see the shape of the reservoir underground under the conditions of natural deposition is going to extend for several kilometers, not going to be just one small packet. So, when you are having such kind of reservoirs underneath and you want to exploit and drill, normally we do several platforms, not one platform and keep drilling in the same location, because you won't be able to access the larger extent. So, you will see that several platforms are drilled and oil and gas are extracted from the location. So, when you do this, what really happens is something like this. You are creating a void below, and which is going to cause instability to the seabed which is lying above, which is a potential problem in the recent days, because when oil and gas extraction was starting to happen 70s and 80s, many of these fields were very young, but after 20 to 30 years of extraction, what you have seen here is the void space created becoming more and more problem. In fact, in North Sea, many of the old platforms more than 30 years, the whole platform together with the subsoil has gone down by 6 to 10 meters over a period of 30 years. Slowly it is going down because the instability has happened. It is not that you are going to see a small pothole happening, it is the whole area of several kilometers going down. So, you won't be able to see a major problem with the structure, but constantly going down at a particular rate, and it will be a potential problem. Initially it will be going down slowly, but once a major fault line forms with a complete area going down, it could actually sink the platform underwater, because water levels are not changing much. So, you will see that the seabed level is going down together with the structure. It is not only seabed, it is the complete layer on top of the reservoir is going to go down. So, what has happened is from 90s to now, several platforms in North Sea as well as in some parts of Gulf of Mexico has gone down by more than 5 meters. Now, imagine we discussed about this problem in design course, where the water level difference, the height between the underside of the structure, the superstructure to the water level, is basically a minimum required depending on the sea state conditions. So, otherwise what happens is sea waves will actually hit the superstructure. Now, one of the problem is the superstructure may not have been designed for that, and the amount of green loading, we call it green wave hitting the superstructure, will be substantially larger, which will make the platform to fail instantaneously, because you have not designed for such condition. Number one, the loads are going to be very large, and also the facilities supported on top is going to be subjected to direct water immersion, which is not very good. So, you may have to change the facilities. That is one side of the story. The second is the major issue is the stability of the jacket itself. When you subject so much of large load, is going to be whether sufficient, and if you have to check such a platform existing in the old, say 30 years, 40 years old, still producing, what kind of criteria you have to use, you may actually have to reduce the requirements. But then what will happen to a platform if you are planning to install now, whether you need to provide for such. So, most of the platform in the recent times which are getting installed, you have to give a provision for seabed subsidence of 5 meters or maybe 10 meters. So, you construct the platform 10 meter high now, higher than what you normally provide. See, for example, if you normally provide a clearance of say 10 meters, you provide for another 10 meters, so that the next 30 years, 40 years, especially when you are installing a platform in the existing area, because it's already is almost gone empty and it's going to go down substantially. So you provide for that. So we call it seabed subsidence allowance. So you plan for future subsidence to happen. So that's why this reservoir simulation is very important. But how can you avoid this? So one of the ways in some of the field people have been doing is filling this area with water, seawater. So for example, you try to create an empty condition by taking out the oil and gas, but then you can fill or refill with seawater. But one of the potential problem is when you start filling, it mixes with the remainder of the oil and gas. When you are actually taking out, too much of water will come. So there is a potential contamination that can happen, which is also a problem. So quite a number of studies are going on area wise to find out what is the rate of this settlement. So many of the platforms, they have put live instruments to measure the rate of settlement, so that you can actually plan for the future platforms. So this seabed subsidence is a potential problem going to happen or waiting to happen for every location. Only depends on amount of white space created because of the pumping. Not every place will have such a problem. You know, some cases you will have porous structure which may be still stable even after removing the or extraction of oil and gas. So not a big issue so far in the west coast. We have not encountered such issues, but if it encounters, we need to plan and provide for future. There is one more issue. Imagine if the whole platform goes down nicely. In fact, quite a number of research studies is going on. If one of the leg is going down because of a local issues and the platform starts to tilt, so what exactly will happen? In fact, some of the universities, they have done some research studies on one of the pile going down, but the remaining 3 is stable. So what happens to the ultimate strength of jacket, whether it will be stable? So pile settlement by say several centimeters, which is one of the issues, because when the whole area is going down, you don't expect everything is going to be a uniform settlement. You may actually have undulated settlements in local areas. The next issue what we want to address is the scour around constructions offshore or coastal. The scouring is the removal of soil in the vicinity of an obstruction created by by construction of offshore structure or coastal structure. So imagine if you have a steady stream of current going and straight away you make one barrier. So what happens is the current velocity is going to get obstructed by this structure. So it will try to find alternative routes. So imagine if you have only one pile installed in the middle of a current, so the current will try to get diverted. So in the vicinity of the seabed and the pile, you will see that increased circulation happening because an obstruction is there. So the soil particles will try to float above seabed. When it was in a static condition, it is lying on the seabed. Specific gravity may be somewhere near 1.1, 1.2 submerged condition, and then when this circulation happens, because of the turbulence, the particles try to get lifted off, and if you have a sustained stream of current, it will get carried away. So this is the simplest phenomena that is going to happen, which will take away the soil particles in the vicinity of the structure because of the disturbance and the circulation that is going to happen. And that phenomena needs to be investigated, and basically because how much amount of soil is getting removed, that much of amount of capacity is getting eroded away from our calculation, number one, and also it exposes the pile to that much distance, become a larger cantilever. So which needs to be taken into account. There are 2 types of things that can happen. Actually it can happen over a larger area, like very similar to our seabed subsidence, larger current and larger thickness of loose sediments which can get carried away and then get removed, which will be not dependent on the type of structure that you have constructed. It could be generally eroding. Whereas the second one is specific to an obstruction created by construction activities, which is basically called a local scour. It will be in and around the structural area where you have put a pile or other obstruction. So, which is called the local scour. Now, this depth of scour depends on various parameters, the current velocity, size of the structure, and the soil particles, basically the surface soil particles. If you have big boulders, probably the current velocity or the turbulence may not be able to lift it off and carry away. It will not be able to possible to do that. But if the particles are quite small, number one, and also not very denser, then you can see that these particles may get carried away because of this. So, you can see now immediately you have a solution. If you make the big boulders around the structure, you can see it may not be able to possible to get scouring. So, one of the scour anti-scour measure is make larger boulders dump around the structure, so that the soil is not able to go away, whichever the soil is underneath. But the problem is, if you put a big boulders, still the void space is there, soil may actually get carried away. So, you need to have a engineered fill, that means the graded fill, so that soil cannot escape. So, normally we do this, the scour protection means trying to avoid the particles going away. So, the scour phenomena is very important, especially in coastal areas, because that is the area where you see a lot of turbulence, wave breaking, and also increased velocity because of the energy is getting destroyed down there only. So, you will see that scour is not a very big problem for jacket type of structures, but still it does exist for certain amount which we need to take into account. But for coastal structures, it is a very serious phenomena where the scouring can be as much as several meters, especially when the current is very large. For example, if you look at Gulf of Cambay in Gujarat and Maharashtra area, the scour depth is as much as 10 meter. The reason is, during neap tide and the spring tide, the current values are almost like 3 to 4 meter per second, 3 meter per second in fact. The reason is the tidal changes is 10 meters. So, during your high tide, you will see that the water levels are so high, and during low tide the complete river, it is almost like a river taking the water from the inside of the Cambay towards the sea. So, it carries complete. So, every day 2 cycles, you can see here within 5 years the scour depth is almost 10 meters. In fact, one of the structure which was built in 97, after 5 years the pile is almost cantilever by another 10 meter. So, you can see that this type of places you either protect or you design for it, So, this local scour and this global scour also needs to be added together, because you may have a general scouring and you may have also a local pit kind of covering, wherein so this general scour typically over a period of long time you may have 1 to 2 meters normally happening when you have a granular type of soils get carried away. Local scour is a kind of phenomena very easy to understand. It is going to be increased circulation and turbulence near that structure. You have a vertical pile or inclined pile, does not matter, only the pattern will change. So, you can see here. So, when we are doing a structural analysis for your jacket structure, we are supposed to get a pile resistance, the soil resistance at the seabed level, but you do not have the soil. It might be there on the time of installation, but after several years it is disappearing. So, that is where you have to take into account. So, when you are designing the structure and the pile, you may have to consider extra 2 meters soil is not there. Now, imagine what is the difference between the local scour and general scour. When a general scour happens, you see the water depth increases by at the site, at the particular location of the platform, water depth increases by this much. Whereas, when you actually look at for hydrodynamic calculations, when you are doing a hydrodynamic calculations, I think most of you are familiar with wave theories and associated calculations. So, you will be using water depth. Now, here general scour is overall area, so water depth is going to be increased by that much. Whereas, when you come down to this type of local scour, water depth is still the same as the original, but then there is a increased the depth at the location of pile, which causes some amount of reduction in the lateral and axial capacity, which is. So, this is what you need to make sure that differentiate between how you deal with this local scour and the global scour. Normally, many places we use a value of 1 to 2 diameter. Typically, that is what happens. Many research studies have shown that it is not going to be very large. the local scour will be something like this, maximum is 2 diameter, beyond which the soil will not be stable. It becomes almost like a global scour, it will take away larger distances. So when you combine them, basically it will be like this. So you see here this much of pile has to be exposed, and you do the design accordingly. So how do we do or how it affects the calculations that we have learned so far? For example, when you are talking about overburden pressure, I think if you remember alpha method, overburden pressure is very much important. Now you can see here the global scour, straight away you can remove the soil. So overburden pressure is automatically reduced by that much. If the 2 meter soil is missing, the 2 meter soil is not there for overburden pressure. But when the local scour happening, you could actually assume that another 2 meter or another 1.5 diameter, 2 diameter soil is completely removed, you can assume like that, but that is too much conservative. So what API says, you don't have to completely remove the soil, because only a triangular portion of the soil has been removed, because sometimes if you assume 2 diameter, say diameter is 2 meter, 4 meter of soil is completely removed for local scour, your capacity reduction can be substantial, because alpha method or beta method, both of them actually the overburden pressure contribute considerably. So that is why there is a proposal by API that you do not need to completely remove the overburden pressure 100% for the local scour. Of course, for global scour you anyway have to remove. For local scour you find out distance at which the 6 diameter, after which the influence of the local scour will not be there. That means the soil becomes almost, you will have the effect of the soil on the vicinity will provide for you as a overburden pressure. So below 6 diameter, that means within the 6 diameter you have a linear increase of the overburden pressure from 0 to maximum value. That is seems to be a reasonable idea, because this is anyway to a local, because when you look at a far away distance, soil in the other slightly away from the pile will also contribute. So that is the local scour model. When you are doing a calculation for your axial capacity including scour effect, you need to take into account this. So which is why we need to learn the effect of local scour into the calculation. Similarly on the lateral capacity, so that is the idea behind. Global scour anyway I do not think it will affect, because you will just straight away assume that that soil is removed, so not a big problem. The next topic what we want to find out is the type of soils, which is relatively important in cases of areas where carbonate content is very large. In fact, every soil sample we do a chemical test to make sure that this carbonate content is less than 2%. If it is less than 2%, contribution of problem associated with downgraded capacity is very small. So what is this? We need to understand soil can be classified into silica rich or non-silica rich. That means is carbonate soils are going to be there. Silica rich is basically our grain sized material, parent material coming from basically quartz or associated rock minerals. So predominantly most of the soils, whatever we classify, whether it is clay or silt, sand, gravel, every one of them the origin is going to be coming from such type of material. So the carbonate soil is basically the calcium carbonate arising from biogenic materials, basically the decomposed plants, animals several thousand years back. So you see the skeletal remains under the ground and get decomposed, forms part of the soil, but it may not be separate, it might have got mixed with other silica type of material and becomes like a soil. It looks almost like you won't be able to easily differentiate, but then when you apply loading, these carbonate content, if it is larger, it's like a honeycomb, get crushed very easily, but you won't be able to really find out from a typical picture of it. So if you just look at this, you can see here this area is having some kind of larger carbonate content. So when you apply a loading from the top, you will see that this gets compressed very easily. So this is where we have to be a little bit cautious in taking samples and take a sample and take to the laboratory, do a chemical analysis, find out the content of calcium carbonate. So that's one of the area where API in earlier time has no recommendation, because you try, what they say is try to avoid, but offshore systems, how do you avoid? If you have a place where you have larger calcium carbonate, then we don't want to shift the offshore platform to another location, because that is where the oil is available. So we still have to construct, but in many of the cities, if you find this type of soil, people don't go for pile foundation, because potentially they can cause trouble at any time, and there is no easy method of treatment available for such type of soils. So the carbonate soils are found in earth crust in many locations. If you actually look at the survey, fortunately in west coast or east coast we have very few isolated locations, but if you go to Middle East, especially the Gulf area, many of the oil fields, the top crust is having this kind of soil where carbonate content is almost more than 40 to 50%. In fact, that is why many of the API procedure we don't apply for that region. They have got a region based specialized calculation methods for pile capacity, which I think I will share with you later on. Slightly downgrading effect. So if you remember alpha method we were learning, alpha method is proportional to your overburden pressure for sand, and so there is again a reduction factor applied on the top of that method to take into account the effect of carbonate content, and that is something practiced in that part of the world. So basically the biogenic soils are composed of skeletal remains of plant and animals embedded into the soil several years back and downgraded. So this is a typical example that will be very difficult to differentiate the normal clay soil from this kind of mixture of soil with this content higher. So easy to disintegrate, that means if you pick up the soil, you just try to squeeze between the fingers, you will be able to see that it is having not much strength. Particle shapes quite angular, not much sub-rounded, and then because of larger particle sizes looks, and it might actually get too much of white space, so the density will be very low. Compressibility when you actually apply loading will be large. So how do we find out this? One of the easiest method is doing a chemical analysis to find out what is the carbonate content, which will give you a feel that this soil is having so much of problem. Grain size characteristics, you can do a distribution curve. Compressibility test, which is normally done in the soil lab. Shear strength anyway will be very weak, as you know, when you do a even direct shear test you will get reduced value. And then the origin of material, which is something which we cannot do by laboratory testing. What normally have you have the area wise study work for the last several years, so you can look at the origin of the soil from the history of the material. So this is the method which you will remember we were talking about 0.15, I think 0.25. 0.25 was the value that we normally use for 0.5 and 0.25. There were two subsegments were there. So you can see here is 0.16, which will yield a slightly reduced value of alpha, which was recommended by a company which has done extensive work in that Middle East region, and Fugro. There is a company called Fugro who does most of the soil works in that area, drilling as well as presentation, and working for many oil companies. So they have proposed, after doing so many tests and some kind of measurements on site, they have come up with the reduced values of alpha, in which case you can use, if you encounter, the condition to use is carbonate content greater than 50%. So that is what they have a predominant condition there, and N bearing shall be ignored. So you can see here the N bearing at any layer you cannot take, because it is going to just give up. So that is the recommendation based on Fugro, and earlier we used to not even have this. Now API says this, they have published in one of the OTC paper, so you can refer to this paper for any particular site when you are having such type of soil. The last one I think we want to see today is basically the piling problems. We have learned about pile drivability. I think during driving, if you expect premature refusal, because you already have reviewed the soil layers, and soil layer seems to be very hard, and you provide for, you do a theoretical assessment, this hammer is required, and still you get prepared for some kind of remedial measures in case if it happens offshore, you do not want to come back and then go again. So you actually get prepared, because the repercussion is very large. If you don't install the platform this season, unlike onshore or coastal areas, you can do it tomorrow, whereas it cannot be done that way. So the piling problem needs to be understood and then get prepared and provide for while going offshore. So that's the idea behind. So what can actually happen when you have a early refusal, because your theoretical calculation of pile drivability is not correct or misunderstood, or you have understood the soil is actually stronger than your understanding, your borehole is incorrectly understood. So there could be pile refusal even after doing so much of engineering work, still you could expect early refusal. Pile buckling, because your pile calculations of stresses was incorrect, so pile start to buckle locally because there is a big boulder, something normally happens. Pile refusal due to soil setup, because your hammer breakdown or weather conditions are not permitting you to drive continuously, you stop and go back again to start driving after say 2 days, you see that the resistance is larger. So these are some of the areas where unexpected things can happen, so you need to get prepared for it. So if you have such issues on site, some idea you can just think about, how do you restart? For example, one of the idea is removal of the plug. So you just remove the soil within the pile somehow. So what happens is the internal resistance is removed, pile end area resistance is removed. So when you restrike, the resistance is reduced, so pile can actually go down. So that means you need to have a machine which can actually remove the soil, which is called relief drilling. So that means you have a drilling machine on board. So while going offshore, you only have a driving machine, now you actually have additional drilling machine. So if you have a drilling machine, I think you should not have a bigger worry. Only thing is you need to, if you have it, if you don't have, this cannot be done. Or you can imagine you have a larger diameter pile and drill and provide a smaller diameter pile within the pile. We call it micropile, we call it several different names, add-on pile. The reason is the pile is unable to go because it got stuck. So if you make a smaller diameter inside, it may go. So these are some of the ideas that you can think about. So plug removal, how it is done, because you don't have any superstructure there. So on top of the pile itself, you will install a small drilling machine. We call it pile top drilling machine. It's unlike a drilling machine used for oil and gas drilling, that will be bigger machine. This one will be a very small, so you can just put it through and start removing the soil. Once you remove the soil, then you can again place the hammer and start driving, and you can repeat this procedure. But one of the issue is what has happened to our original calculation. See, we assumed that soil is inside the pile, soil is outside the pile. You have done a calculation for skin friction outside, skin friction inside, end bearing. Now the soil is not there inside, so your design calculations for your engineering capacity is not correct. So we need to either make sure that you fill the soil back to achieve a similar density, which is very difficult, or you fill a material which is better than the soil. So normally what we do is we do a filling of grout, which will be far better than a loose material which you are going to fill. So that's why. So you can imagine now, when you expect such things to happen, you need to have a drilling machine, you need to have sufficient amount of material to make a grout material, and also to methodology to fill up the grout. So these are the things that you. So how do you evaluate whether this is going to happen or not? All depends on your understanding at site and the boreholes and the vicinity, what has happened in the last few projects. If you have expected similar things happen, so you get better go with that kind of idea. The other thing is basically installing a driven micropile. That means The reason why we can understand the reason why the pile is not going, because a larger diameter means larger capacity or larger resistance. So, you make the pile smaller, you may actually have lesser resistance because it is going to go inside, and that is the idea behind installing a reduced diameter pile, which we call it micropile. The effort required to drive that smaller pile may be slightly smaller than the bigger pile, but you already have the hammer which was driving the bigger pile. So, that means it may be able to easily drive the smaller one. So, that is the idea behind driving a micropile straight away within this. As long as you already have thought about it, you have taken the material. If you do not have a material, you may not be able to do it. So, that is one idea. The grouted micropile is just an alternative to this, because if you are not able to drive, then you actually drill the soil within which, and then you insert this pile and then do the grouting. So, what happened is, whatever the capacity you could not achieve, because the pile supposed to have gone to this place, supposed to be original design, will be derived from the pile that you have inserted. So, that is the idea behind. So, we need to just make sure that that capacity is sufficient enough. So, grouted micropile versus driven micropile is depending on the type of situation. If you have a very hard layer like sandstone or rock, then probably driven micropile is also not going to work. So, you may have to do a drilled micropile. In some cases, I think I have shown some video, one of the, I think sometime, you have a complete, the pile itself is drilled and grouted, you know. So, you can have a situation wherein you can't think of driving because of the soil is in shallow depth itself, you have a hard material. The last one, I think we were discussing about this connection between the leg and the pile. The grouted connection, anyway, we have already gone through the design methods adapted. The other one is basically the crown seam connection, wherein you do not have any grouting. The load transfer is only through contact at every horizontal support framing of the jacket through a seam connection. Basically, you see the green color, hope you are able to see, within the leg you actually install a plate which is tapered in nature. So, wherever you have a load on the outside sleeve or jacket, the load is trying to push the jacket towards the pile, because the pile is already anchored into the ground. So, this when the contact happens, the load will be taken by the pile. So, the gap supposed to be smaller. If you give larger gap, you may not be able to get the load transfer properly. So, that is why we give about 6 mm gap, but one of the problem is the smaller the gap, installation of pile becomes a problem, because if you have a smaller annulus gap, when you try to install a pile, because of the fabrication tolerances, pile may not go through. So, what we do is we give a larger gap, but then we give a chamfered surface by which the pile will be able to somehow insert into it. So, this will be installed in every horizontal framing of the jacket, so that the load transfer happening at the strong points. And the top connection is a simple plated connection, will be welded to the jacket as well as to the pile, so that the jacket and the pile is not moving away separately, something like this. So, the reason why we made a we have got this kind of zigzag connection is to increase the length of the weld. Otherwise, you will have a one circumferential weld which will not be sufficient enough to take a larger moment connection there. So, you just have looking at something like a crown. So, that is why it is called a crown plate or crown seam connection, which is very much essential to make sure that the pile load transfer at the top happening through this moment. The remaining is only a contact surface. There is no other place there is any welding is going to be done, because all are underwater. So, you do not expect. So, that is why sometimes this type of method is not preferred, but then when the jacket water depth is more than 100 meters, you can't imagine of thinking of doing grouting, because grouting will take several days. If the grout length is about 10 meters, you may take 1 day. If it is 100 meters, only grouting will take 10 days for each pile, which will not be possible to stay there in an offshore environment. So, that is why we go for a ungrouted pile system, mostly water depth beyond 50 meter. Pile sleeve grouted connection, I think we have already covered in the other classes. So, these are some of the areas, I think if you look at it, these are some of the special problems which you need to remember when you are doing the pile foundation design.